All right, so let's get the picture here. We have two boats 50 miles apart from each other, with boat A being west of boat B. Again, I'm going to be labeling the side lengths A and B. I'm not going to label the boats A and B, right? But let's see what they're doing. So boat A travels north. So A is going north, so I'll put the A there and get rid of that little thing. And then I can say, oh, dA over dt is a positive 45. And let's see what the boat B is doing. B is traveling south. We haven't had one like that. Oh, and look at that. My B is right there beside the length. So dB over dt is 60. So both of these lengths are getting longer. And then I neglected to put the 50. The 50 is right there in between them. So what am I trying to find? I'm trying to find the distance between them changing. Oh, two triangles? Let's not. How about we transpose? So let me show you what I mean. So here I've got this A, right? So that's the length of A. And then I've got the length of B. And then I've got this 50 between them. And then here, let's call it C, between them. So do you see what I did? I took this A and I moved it over here. And so then I've got a triangle with A and B as one side, the 50's fixed, and then I'm trying to find the rate the C is changing. So looking at this, my equation will be C squared, A plus B squared, plus 50 squared. Okay, now I'm ready to take the derivative. So 2c dc dt, and then you're looking at chain rule happening here, right? 2a plus b to the 1 power, and then dA over dt plus dB over dt. So that has to have parentheses because that's the derivative of the inside, right? And you know the derivative of 50 squared is 0. Okay, let's see what we got here. So let's cancel the 2's and make some room over here. So let's think about what's the when. I neglected to write it down, didn't I? So there are 2 miles. Oh, what's the change of distance after 3 hours? So when t equals 3. Now we can use that. So if I know that A is moving at 45 miles per hour, and I multiply it by 3 hours, that gives me 135 for the length of A. And if I know that B is moving at 60 miles an hour, and I multiply it by 3 hours, I get 180. So that's what the B length is. So let's plug those things in. So I'm just going to carry it down here. So I have C dc dt equals, so A plus B will be 135 plus 180. And then, oh, you know what these things are, right? We know those, so we can just plug those in. 45 plus 60. Okay, so what's left to solve for? All we need to do is solve for the C. I know that A is 135 and B is 180. I think we can just use Pythagorean theorem, right? So I would say that C, let's see if I can put it down here, C will be the square root of 135 plus 180, so that gives me 315. So 315 squared plus 50 squared. So I'd put that down here. 315 squared plus 50 squared, and then I would erase the C. There it is. So I don't want you spending time on the calculator to compute that number. This shows me you know how to solve the problem. Just leave it like that. On a test or a quiz for sure. All right, one more here. So we've got this conveyor belt dumping out sand, and I want you to know what that formula is, and I kind of mentioned that in the notes, right? So the volume of a cone is like but it's falling. Look, sand is falling into this like cone thing, like right that. 1/3 pi r squared h. Okay, so this is telling us volume, right? Cubic meters. So dV over dt is 15, and it's growing, so it's positive. And let's see, what are they asking us to find? They're asking us to find the height. So find dH over dt. And then what's the when information? When the pile, when h equal 8. Oops, move that back. Okay. It's messy. H equal 8. Can't use that yet, right? Gotta save that for later. So here's where the dilemma comes in. So if I start looking at what I've got and what I need to find, I've got dV over dt. I want to find dH over dt. So I've got V and H in my equation. Oh no, I need to get rid of R because I don't have any information about dr over dt. So before I take the derivative, I need to get rid of R. So let's think about it. I'm going to use space up here. Do they give me information about how what the radius is? Maybe related to the height? What do they say here? Let me erase so I can see it. So they say that the height of the pile is 1/4 of the base. Okay, height of the pile is 1/4 of the base, and the base would be, the diameter of the base. Okay, you know diameter is 2 times the radius. And remember, I want to get rid of R, so I'm just going to take this up here. So R over 2, so I'm solving for R. So I'm going to substitute this in, right, oops, did I erase the H? Oh goodness, what happened here? 1/3 pi r squared H, right? I think something happened. 1/3 pi r squared H is the formula. I am going to substitute in for R to H. So let me bring it down here. 1/3 pi 2H squared times an H. Definitely, absolutely simplify this before you take the derivative. So I have 1/3 pi, and you know you square both of those. So I'm just going to go slow to make sure you see it. All right, volume is 4 pi over 3 h cubed. Oh, this is going to be a nice, easy thing to take the derivative of, right? So dV over dt, carry along this 3h squared dH over dt. Okay, so I get to plug everything in. So let me bring it up here. 15, right? That's what that is. And I'm going to cancel the 3's. So equals 4 pi. And I've got h squared. Do I know what h is? I do. 8 squared. And then I'm multiplying by dH over dt. That's what I'm solving for, right? So I get 15, divided by 4 pi times 64. That's a fine answer, just like that.